Hello, candidates. Very good evening to everyone. I hope everyone is doing well. So before I just continue, I want anyone to confirm me whether am I audible or not. And I have already shared my screen. So got it. Perfect. So guys, in the last class, we have already completed the project and it was completely related to the convolutional neural network, right? So today onwards, we are going to start again another or like the final project, you can say, and this is completely based for the RNN part, right? So RNN plus model project as well. We'll try to understand what is the use of RNN and then the final project building as well, okay? So when we talk about artificial neural network or like the deep learning, so deep learning, we know that it's broadly classified into the basic neural network, which is like artificial neural network, and then followed by the convolution and then the RNN, right? Whenever we are getting candidate the data set related to time series data, textual data, or any sort of speech data, we'll generally refer this as a RNN. RNN is like recurrent neural network. And recurrent is something we are training our model again and again, again and again. It's like recurrent means doing something on a repetitive stage. Okay, let me just simply check the meaning for this. Recurrent meaning. So it's like something that occurring often or repeatedly. So if we are saying this as a recurrent neural network, so it means we are not particularly creating multiple head of layers here, right? We are just simply giving one set of like a hidden layer one or two times, and but we are just keep training that model again and again, and that makes this as a recurrent neural network. Okay, so let me just first show what exactly that we have to do in this. Inside this recurrent neural network, we can first start with the textual data set, okay? Then piece data set, and then followed by the finally time series data set, right? So if you want to perform the NLP related task, NLP is like natural language processing. Then you have to use this RNN concept, right? RNN is like recurrent neural network, and recurrent means we are training something on a repetitively basis, right? So let's just understand how exactly these neural networks work, right? And we have to understand some set of tokenization concept, yeah, like vocabulary concept and the corpus concept and all, right? So suppose let me just go and just check the essay on India, okay? And suppose I want to create a model where this model particularly gives the same result. If I just simply go and search for the essay on India, okay? The difference between the Google type of search and the the GPT or LLM kind of search. So LLM is like it try to generate the data, okay? That is the reason we are saying this as a generative AI, right? But when it comes to the Google type of search, so it will just go and search for their indexing, and based on that indexing, it will like give out the result. Okay, that is the main difference between the generative AI and the Google search engine. Okay, now suppose we are getting this answer from the generative AI or any sort of LLM. So how to exactly train our model based on that, right? So first it will try to convert all data into tokens. And what is tokens? Tokens are like the individual word or like the unique word that you have. So what you will do, let me just first simply store this inside of data. This is my complete data. If you just simply check the length of this data, so you will something get 341, right? But here you can just check now, we are getting repetitively word again and again, like is we have, in are repeating like multiple times. So we need to just extract the unique data from that particular given word. Okay. So let's just try to get that word. How to do this? You can just simply either use the NLP module. NLP, we have that module that is called NLTK. NLTK allows us to write or perform some sort of natural language processing tasks. You can just simply go and Google for pip install NLTK. Okay, NLTK, with the help of NLTK, we can particularly treat our textual data. We can remove the unwanted words, or we can stop the unwanted words as well, right? So you have to install this. But I am just showing you the basic and traditional approach of how to particularly convert our data into the meaningful tokens, right? So inside this data, let's just do some Pythonic approach. First, you will just convert your all data in a lower case. Then you will use the strip method. And with the help of this strip, I'll just try to strip my data whenever you are getting any sort of any sort of extra spaces at the starting or at the ending of this data set, it will try to strip out all those values, right? Now let me just split that data set, and I'll use the space to split my data set. It will convert my each and individual words into the tokens. Okay, let's just wait for this to execute. And meanwhile, I'll just go to this one. I'll just select the change runtime because I have to train a model now. So let me just change this to TensorFlow, right? Or like a GPU's access for the this particular model that we are going to create using the Google Colab, right? Okay. So just a look at this. We have simply converted our data into the individual tokens. This India is nothing. This is a tokens, right? But the problem is that we will get India multiple times, okay? And we want a unique corpus, right? And let's just do one thing. You can just simply store this data, or you can remove the unwanted or unnecessary words. For that, either you can write the Python approach or you can use the NLTK model. NLTK already gives you that how to remove the stop words. Okay, and we have another technique that we generally call as a lemmatization technique, or like the stemming technique, where we just want to find the stem word. Okay, just look at this. Here we are getting the India, and the another word is Indian. Okay, so there is a similarity between this Indian and the India word, right? So we want to just find the root word, and that technique is called the lemmatization. We just find the root word using that particularly given set of words, right? So let me just go and show you this. What is the lemmatization? Lemma of word Indian or India. Okay, and this will give you the lemmatization concept. Okay, so lemmatization is something like it will break down the word into their root word. The actual word is Indian, but the lemma word is India. The actual word is India and the lemma word is Indian. Same as it is if you are going getting data something like this: go, gone, okay, go, going, like this, and gone. And you can just again go for this. What is the lemmatization of this word? So you know that these are the different set of verbs. So you can just get the lemmatization word of this one: go, going, gone. We have the main word that is called go. So we can simply convert this going to go, gone to go, and went to go as well. This technique is the go is called the lemma technique. And interview generally asks you what exactly this lemmatization. So we are just trying to find the root word of the whatever word that we have. Either we can use the Python approach, but we have an NLTK module that allows us to particularly perform all this one, right? Okay. Now, if you want to remove all the unnecessary words, so you can use this one. Let me just go to this. Yeah, and we have this method that is called replace. And inside this, we can just say, okay, whenever we are getting any slash and the, let's just try to replace with the blank space one, or like with the none one. You can just simply do this. And the data is not defined. Where the data is not defined, let me just run this, and now again run this. Now you can just check we are not getting any set of words, right? So we can simply refer this as a tokens, right? So right now in this word, let's just convert this in a set of tokens. These are called tokens. And whenever you are working with any sort of NLP task or like any LLM kind of solution, so you have to be very tokens specific limited, right? Now you can just simply go and check for the tokens one. So you can just print the tokens, and let me just print the first token. These are my tokens. And if you want to check the length of this token, so you can just simply go and check. Okay, previous we were getting the overall length of the data as 341. Now we are only having the token word as a 47 word. But in this token word, now we are having some sort of unnecessary word. These are called stop words. The, and, is, a. These are like my stop words. If we want to create a model from scratch, so we can eliminate all these stop words, right? Let me just show this. Stop words in NLP. If you just write this, so these are the examples. The, is, at, which, that generally does not contributes any meaningful information in your the whatever the data set that you have. These are like your stop words. If you want to remove all the stop words for your model training, so you can definitely use this one, right? Okay. So now we have the overall 47 tokens. Now, what about the unique vocabulary that we have? So unique vocabulary is like if we are getting multiple words multiple times, so we will not treat this as a vocabulary, right? So what we will do, we'll just simply convert this token in a set. So let's just convert this token into set, and then again we will typecast this set to list one. And finally, this is like my vocab. Vocab is like we will only having the unique word at once, right? And this is like my vocab. With the help of this vocab, let me just check the length of this vocab, right? You can simply say this, okay, whatever the data test that was generated by my model, it should be based on this vocabulary, right? Here you can just check, we are getting the 47 without the vocabulary. It like the 7 words are repeating multiple times. Now we are having the 40 words, and these are like my vocabulary. Now based on this vocabulary, you can convert your data into the vector embedding, or like we say this as a one hot encoding. Okay, so we can simply relate this. Okay, let's just do give a ranking of this unity to 0, largest to 1, Himalayas to like Himalayas to 2, nation to something this, languages to this, land to this. Okay, so how to do this? Let's just call the range function, and you can just say, okay, I want a range, and I just want a range of for my vocab. Okay, this will give you the range. And the second thing that I want, I just simply want to zip this data set. We have this vocabulary, and I want to zip this data set, this data, we have this data set, this is called vocab, and let me just zip this. Zip is like we are just merging two objects into the one, just like zip function, and let's just simply convert this to dictionary, right? So now you can just simply give your like embeddings to your data set. So right now you're not treating your textual data to the textual format. You are just treating your textual data into the like integer format, or like the numerical format. So you are just saying, okay, I'll just pick my unity as 0, largest as 1, Himalayas as 2, nation as 3, languages as 4, land as 5, beauty form as 6, right? And as Indian as something 8, 9, 10. And these are the unique vocabularies now you have. So can I just say this as a vocab index? Okay, let's just simply say this as a vocab index. So if you're dealing with the natural language task na candidate, you either you have used this, like either you already have this concept, which is NLP module, or you can use your Pythonic approach as well, right? So I'm just showing you how to deal with this help of a Python concept, right? Not with the NLTK, although you can use this, and it is recommended to use the NLTK when you are dealing with the RNN or like any sort of language processing problem. Okay, now let's just try to convert this data into the like word tokens that we have. These are my word vectors now, so I'll just simply convert into my the values, right? So you can just simply call these tokens, and the tokens are like, I'll just simply try my for loop for I in whatever the tokens that I have, and inside these tokens I'll just use my vocab index, and vocab index, I'll just pick my key as a I, and I know that I have that I particularly, and I'll just print that particular I. And let me just store this as a data num. Data num is like my numerical data, and I'll just call this one, go to this data num, and simply append this vocab index, right? Okay, now let's just run this. And now you can simply check your data num. So data num is like the numerical representation of your text. Now you can just check. India is at the 38 index. So you have simply converted your data into the like data num. Now you can just say, okay, because we have this numerical data now we can simply create our model for the natural languages processing, right? But this is just a dummy concept candidate. In the practical one, you no need to simply use this Python approach, right? We have some sort of spacey module like NLTK module we can use, SciPy module we can use to convert all the data set via like with the help of a vector embedding or like the count vectorizers. Okay, let me just show you what exactly the one hot encoding and the vector embeddings is, right? So one hot encodings. Inside the one hot encoding for NLP, let me just write this as one hot encoding for NLP. So this is like you're just particularly treating your word, each and word as a vocabulary word, right? And you will just try to convert the into the meaningful vector, and this is called a sparse matrix, right? Okay. Hello, I am Iron Man. I have Friday AI. This is the text. Okay, just you can ignore the semantics or like the set of sequence, right? Now we can simply convert this into the one hot encoding. Okay, how to check? Okay, first you have to count the overall vocabularies or like the tokens. Inside this particular paragraph or like a data, we have this set of tokens, and these are like my vocabulary. AI, Iron Man, Friday, have. You can just ignore the like the sequence of this data set, right? Now, whatever the metrics that you are getting, it's like 1, 2, 3, 4, 5, 6, 7. So you will just try to represent one word by one vector and then followed by the 0, 1. Okay. You are getting the Iron Man na? So you will just write the Iron Man at the second index and then rest as the 0, 1. The Friday is at the third index 1 and rest with the 0, 1. This is called the vector representation, and this is like a one hot encoding representation of your data set. Now just look at this. If you want to pass this data set to the model, so instead of this hello, you will pass this one 0, 0, 0, 0, 1, 0, 0, and I am, you will pass this I as 0, 0, 0, then followed by this, and I am, you will use this one, right? Same as it is with the Iron Man, right? And this is called the sparse matrix, where you can convert your textual data into the one hot encoded vector. But just look at the amount of data set. If we are getting very huge amount of data set, so this one hot encoding will create some sort of model overfitting. This is like problem for us model training, right? So what we will do, we'll just try to particularly use the vector embedding technique. Now, vector embedding is something like, we say this as a word embedding, okay? Word embedding. Inside this word embedding, we'll just randomly apply some features to our data set, right? And the features are like, let's just pick the example of this, okay? Suppose I have some sort of data set is like king and then queen, okay? These are my word, and I want to convert this one into my vector embeddings, right? So how to do this? First, you will give some feature mapping, and this feature mapping are randomly decided by the neural network, okay? So this is like whether the king is a male, okay? This is my one feature, and instead of directly representing this as a male, let's just give the feature as a gender, okay? Uh, will this king is related to any sort of rule? Yes, we can give the feature as for that, right? Okay. King is like related to any sort of kingdom. Okay, you can just simply like this one. King is related to any sort of kingdom or not, right? And the fourth that you can give is like whether the king is something it is related to war and all. These are the features that you are particularly giving, and etc. Now based on that you will give some value. Okay, if the king is male, then you can give 1. Okay, well, if whether the king can rule or not, right? You can give some sort of value. Yes, it can rule up to the 98% of value, right? So you can just write this one. Okay, the king is like belongs to any sort of kingdom. Yes, it belongs to any sort of kingdom, right? King, all kings participate in the war, so you can just give no, all king not participate in the war, and same as it is some sort of any features, right? And you can just say, okay, king, the way we have a like gender for the king, so in the same way we can give gender for the queen as well. Okay, now you can just say, if we are referring this as a king as gender 1, it means the male one, so we can just say this as a -1. It's like this is opposite gender for the king one, right? She can also rule, so you can just give some sort of values like this. These are the vectors, and the values are decided by the neural network itself, right? Yes, she can also rule. You can give the values like something 1 as well, or like 0.98 or something as well, right? Let's just give the vector value to like this, and this is same as it is. Okay, so whenever we are getting any king word now, so we will not simply represent the king with the form of like any sort of indexing. We will just try to give them as a feature mapping, because based on that feature mapping, we can perform the concept which is called the cosine similarity, and based on that we can identify whether the king and queen are closely related or not, right? And you can just simply plot the 2D graph between the king versus queen, and if they are very closely related because of the cosine similarity. And what is cosine similarity? You are just checking the cosine or like the cos angle between the king and the queen, right? So these are called my vector embeddings. Okay, and the embeddings values or like feature has been decided by my model itself, right? So you can just check, right? Cat. And these are the features that generally randomly picked by the model, like living being, like human, gender, royalty, verb, and plural. These are the features. And you are just rating your cat based on that features. Okay. Now you're plotting your all the like textual data set in the 2D graph. Okay, by after using the dimensionality reduction, which is called the PCA, principal component analysis. Okay, now just look at this. This cat and kitten are closely related, and you can just say that cat and kitten belongs to same group of family. It's like cat and kitten are closely related because of their cos angle, and we say this as a cosine angle, right? In the same way, we are performing this man as a vector embedding. This is called the word embedding, and we are plotting that data. And now you can just say कि man and woman and king and queen are closely related. If I just say what is man and woman, so you will get the answer of king and queen as well. If the man is king, So what will be woman as what? So model will give as the answer as a queen because it will check the cosine similarity or like the cos angle between the given words or like the vector. And this technique is called the vector embedding and like or the word embedding. So whenever we are dealing with the recurrent neural network now, so we have to understand this set of concept, right? Now, why we are saying this as a recurrent neural network? Okay, now just look at this. Look at this data. Okay, so whatever the ANN model that we have, just imagine for now, we will pick this data, India, and we will convert this data into the numerical one. Either you can use the vector index, this is like the basic index, or you can use the word embedding techniques, okay? Word embedding techniques, or you can use the one hot encoding techniques. You have three different techniques that you can use, right? One hot encoding techniques. Perfect. Encoding techniques. Okay, one hot encoding techniques, right? ENCOD. Perfect. Okay, now just look at this. Inside this, particularly this data set, why we are saying this as a recurrent? Because it will convert this data set into the numerical one and it will feed to the neural network. Just assume for now it is ANN, right? So what it will do? First, it will reiterate this India. If we are getting India as the input, so the output that we will get is the is my output, okay? And this behaves something like this. You have to create an input and output labeling data. If India is the input, so the output will be the. If India, let me just write this again. Okay, if India, the will be the input, then the output will be world. You no need to do this manually, right? You have to create a model for that, right? If India, the world will be my input. India, the world's, okay. So the output will be my largest. Now just look at this. Look at this level of complexity that we have to work on the natural language processing or like any sort of text generation. This is like my input data and this is like my output data. And you have to reiterate this multiple times. First, during one iteration, you will feed your model as a India and it will predict the output as a word as a the, right? Then during second iteration, you will give India the as an input and then it will predict words as a output. Okay, it try to learn, right? The model will try to learn. In the third iteration, you will give India the words and it will predict output as a largest, right? And now you have to reiterate the same process again and again. During fourth iteration, this will become input data and the output will be candidate democracy. I hope everyone is getting my point. Yes or no? Guys, is there any doubt or any sort of issue? Let me know, class. Are you getting my points now, everyone? Right? So in this way, in the RNN model creation, we have to feed the data set like this. We'll not run the for loop and all, right? The model itself just try to decode the data and will feed the data in this set of way, right? Now, during fifth iteration, this will become the fifth input and the output value will be like and. Okay. Now, during sixth iteration, the input data will become something like this, democracy and seventh will be your the output. And you have to follow the same step again and again. Now just look at the complexity, right? So right now we have only this data set. Now let's just assume we want to train a model based on entire internet data set. And that makes that model as a large language model. That is the reason we are saying this as a large language model. It's not like the model is just only learning all these words. How it's learning? It just try to mapping. Okay, whenever we are getting India, we will get the word as the. If we are getting India, the world, the next word will be worlds. If we are getting India, the worlds, the next word will be largest. Now just go to this India, the world largest, and just go to this. I'll just simply go to ChatGPT and I'll ask, what is my next word? Okay, predict next word. It will use that concept because the model has trained multiple times over this. Whenever we are getting India the world largest, so it will predict that value, right? Let me just check this one. Predict the last word, and this is again the problem for the RNN, right? We have to do this multiple times. Predict the last word after the largest, right? Now just wait for the answer, right? The most likely completion is the democracy. Yes, you know, guys. India, the largest word, democracy. So let me just check. How did you know this? Right? How did you know this? So it will just say because the model is trained this, the model has seen this pattern multiple times. Okay. I predicted democracy based on the probability and common uses pattern in English, right? Once upon a time, see, model tried to say the capital of France is Paris. Once upon, mostly we will use the time whenever we are like feeding this word. So the most probably next word will be time, right? So that is the reason. The model has using the probabilistic approach, right? It tried to predict the value. Now just look at this. Can I just say, are you learning something like this? Let me just copy this. And do you use this set of learning like RNN as example given below? Okay. And let me just paste this one. This is like my input data. Okay. And just assume one thing now, we will not feed the data in like the textual one. We have to convert the data in the numerical one. But just for understanding, we are giving the data, right? Great question. See, we are not using the classical RNN. RNN is just an example, right? But the idea of predicting the next work is step is similar by similar, right? You have to find the next token predictions, right? India is the input, the is the output, right? The exactly how older language model like RNN works, okay, and LSTM works. But right now we have the concept which is called the transformer concept, right? And you can just check the transformer architecture. Since 2017, this was the previous approach, and we generally use this one, right? And this was very popular one before 2017 era, right? The RNN is like recurrent and the LSTM generally work on this, but right now we are using the transformer architecture, and this is completely based upon the self-attention mechanism, right? It will try to just check the forward and backward words that are closely related, and which word that I need to most focus on, that is called self-attention mechanism. And the Google has published this paper on 2017, right? But before to just directly understand this transformer architecture, this is the part of the generative AI field, you have to simply understand this RNN concept, right? And that exactly how older language model like RNN and LSTM work. Now you can just check now. So we are just understanding the same thing, right? So these are the problems that we generally tackle inside the recurrent neural network training. Now let's just understand how exactly this model works, right? RNN neural network, okay? RNN, we know that it's like a recurrent, okay? Now, during at each iteration, you are just feeding your data, okay? And that is called unfolding. You have to use this one, okay? And that is completely based upon the timestamp T, okay? In this neural network, guys, you are getting this kind of like looping or mechanism. This is like we are, whatever the output that we are giving now, or whatever the output that we are getting, we will again feed that output inside the model. Just look at this. We get the output as a India, the world largest. India, the world is my input and the largest is my output. Now, what we'll do, we will feed that same output with the following input. The following input was like India, the world largest, and it will predict the next word as the democracy. Then again, we will feed that data for my model, and that is called looping mechanism. Okay, that is the reason you are getting the arrow something like this at timestamp 1, timestamp 2, and timestamp 3. Let me just show this with timestamps, right? Because then you can probably understand how exactly all this neural networks is working, okay? This technique is called unfolding technique, okay? Okay. Let me just open this image, right? Okay. So now this is my simple RNN neural network. You will give some input data, you will get some output data. And this looping mechanism is called folding technique, right? And let's just unfold this. Unfold means you are just trying to understand, okay, what exactly running behind this and like behind this mechanism, right? So you are just feeding your data data at time is equals to t minus 1. Time t minus 1 is like the previous timestamp. The current timestamp is t. You can start with the time as t, right? So you are giving any x sort of data. X sort of data is like, let's just, we are feeding the data as, this is like, let's just take this as a time t, okay? At time t, we are feeding this input the as an input, and just assume one thing, we are not directly feeding input the, we are feeding this in a form of word vector or like word embedding or like a one hot encoding technique, okay? So we are feeding this as a at a timestamp of t. This will perform some sort of calculation, and we are already aware of that. This is a single neuron, right? And it will do some summation part and the activation part, and it will give any sort of output. And you are getting the output at OT. OT means you got something at time is equals to t. So this is my xt input, and this is my output t. Okay. Now, if this is my at time t, what about this one? So this is like for the time t minus 1. That is the reason we are saying whenever we are getting any sort of data, so that was completely based upon the time t minus one. Okay, at time t minus one, we were feeding out India as the data set at input part, and we were getting the as the output part, and that is at my time t minus one. So you can just check here. I will feed India. I'll get the output as the. Let me just take a screenshot of this. Okay, then you can probably understand. I'll go to this paint one. See, this RNN is very simple and very easy, and but the problem is right now it's not market specific, because since the like when the transformer architecture was launched by the Google itself, so this model right now does not play a crucial role in model training, right? Okay, so let's just write the time t minus one. It's like my India data. Okay, this is like at India at time t. India. When I pass the India at time t, what I'll get candidate as the output? I'll get the output as the. Okay. And just for understanding, I'm writing this in a textual format. But understand one thing, we will not get the textual output, right? This is the da. Okay. And one more thing, whatever the output that we are getting, it should be in the numerical output, right? Then we can further remap this data set. Okay. Now at time t, you will again feed your data, and the feeding your data is like the previous word plus the output word, previous word plus the output word, and the next word itself, right? So you are just whatever the output that you are getting, you are again feeding that output with some sort of weights we already knew that, right? You're just whatever the output that you are getting, you're just again feeding to that looping mechanism, and you are again feeding the next word. So what is my next word? The next word is like my world. Okay, so we are feeding the here. So the will become the will go here. Let's just write this as the. Okay, let's just use another color, right? Because the black and black matching, right? So the will go here. Just write this one again. Okay. Whatever the output that we'll got, we'll just feed that output here, right? The will get here. And now just look at the time is equals to t. This is like my time t minus one. Okay. Now the output will be like India and the. Okay. And I will get the another output. So the output will become something, the input will become India and the. And the final output that we will get is the worlds. So now at this stage, you will feed this one. Okay. You will feed this one, and you will get the output of what candidate? You will get the output of worlds. Okay. And whatever the output that you are getting, then again you have to particularly feed that worlds. Let me just write this as a worlds. Right? Perfect. I hope everyone is getting my point, right? This is the output. Now you have to particularly give that output to the same model. So to the same model at just different time stamp. It's like time t plus one. Worlds, WRLDS. So you will give the worlds as the input for that at like the same model at different time stamp. And then you will feed the same data set like India, the worlds, like this. We are feeding the same data set, India, the worlds, and we are getting the worlds, and we are particularly getting the new output. And let's just feed that data. So India, the worlds. Now this time the data set becomes like this. Okay. And then you will get the same output. This is like my at time is equals to t plus one. And what you will get candidate, you will get the output largest as the output one, right? So this is all about the actual working of a like recurrent neural network. I hope everyone is getting my point, candidate. And this is like at different time stamp one. Now just look at this. In the same way, you can just reiterate the methods multiple time again and again, again, right? So it's like one iteration, two iteration, three iteration, four iteration, and whatever the length of data set, we have to train that model 341 times with different timestamps, and that makes this as a recurrent neural network. And whatever the final output that we will get, it will particularly have like all the information. If we are giving any of the set of like input data, it will just predict the last final value as an output, and that makes this as a recurrent neural network to particularly train my NLP task, right? Or to train my any sort of language processing task, right? So you can just check. This is the actual wording of a like working of a neural network of like RNN neural network. I hope everyone is getting my point, candidate. Okay. Is there any doubt or any sort of issue related to this one? But the problem is this is all like old model. Now the market has shifted to the transformer architecture, which is completely based upon the self-attention mechanism, right? So in this way, you will just feed out your data inside the recurrent neural network. Then this becomes the final neural network, and then you will get the final data. This is like the actual ANN, and this is the like recurrent neural network. And why we are saying this as a recurrent? Because we are giving our data or training our data again and again. And RNN completely divided into multiple parts, right? So RNN has like, if the context length becomes more, so it will try to forget this like previous word or like the previous. See, just look at this, the last word, right? So the last word will be like, it has to particularly pick all the context. This will become my input, and that one become my output. Now, once you just give this length as an input, just to predict this model was as an output, so you will eventually forget all the inputs, like just assume this one like India, the world largest. You will try to forget the previous data, and that makes this RNN as a disadvantages of this model, right? And that's where another model came into the market, that is called LSTM. LSTM is like long short-term memory. Okay, this is the upgraded version for this RNN neural network, right? Something like this. And we have another RNN that is called bidirectional RNN. Let me just write this. Bidirectional is right. It will try to learn both the pattern in forward and the backward direction, right? So this is like my bidirectional RNN. We have created this model, India as an input and the as an output. Now let's just create and read this from the backward, right? Modern will become input and with will become output. Modern with will become input and the tradition will become output. Modern with tradition will become input and the blending will become output. So this is like my bidirectional. It will try to understand the overall pattern of my forward pass and the backward pass as well, right? We have another RNN module that is called long short-term memory, right? And we have another, that one is called the GRU. GRU is like the particularly gated recurrent unit or like gated recurrent neural network. Okay, so these are the things that we generally have to follow when we are working in the any sort of natural language processing task, right? These are the things. Okay, so interview generally ask you, okay, what exactly all these models and what exactly the common architecture of all this one, and these 10H are nothing, it's like the activation functions. Okay, so let me just copy this one. Now let's just try to build the model for this RNN, and then you can probably understand, right? So I'll just simply paste this image here. Okay, you can take a reference of this, and let's just try to call one data set where we will build a project, and the project is all about to predict the sentiment. Okay, where to use the RNN? If you are getting to like, if you want to summarize any sort of messages, so you can use the RNN. If you want to predict the sentiment of a given reviews, like whether the given reviews is a positive one or like a negative one, so you can use this one, right? This RNN architecture, right? So we have one data set, and the data set is very popular one, that is called my IMDb data set. Okay, and with the help of that IMDb data set, let me just show this IMDb data set for RNN. Okay, so you can particularly create a model, and where you will give out all your data set, and you will train your model from scratch using the RNN, and the rest of the rest concept will remain same. And then based on that model, you will create a website. You will just simply paste any sort of movies reviews or like any sort of reviews of related to IMDb movies, right? And it will just try to predict whether the given movie reviews is a positive review or like a negative review. Okay, so let's just call this step 1 to load important modules, import numpy as np. Okay, import TensorFlow as. Okay, guys, I'll do one thing. I'll just go to this one. I'll just go to this setting. I'll just use this one AI assistant, right? Show AI powered inline compilation and consent that I am giving this, because it will take so much of time if I just simply write every code again and again, right? So let me just give the consent for this. Now it should show some like sort of suggestions for me, right? So let me just write this import TensorFlow as TF, and from TensorFlow, yeah, we are getting the hint now. That is the reason. From TensorFlow import Keras. Yes, we want to call this. From TensorFlow dot Keras we want to layers. Yes, we call this. import matplotlib, perfect. You have to just simply hit the tab button, right? So let's just call from TensorFlow, call IMDb dataset as well, right? So we want to call sequential as well, dense layer as well, yes. So let's just write this as a, hit the tab button, right? So Keras.models, and we will call the sequential Keras.layers. Let's just call the dense model, and we want to perform the embeddings as well. Na? So let's just call the embeddings as well, right? EMBEDD. I'm not getting the hint, right? Embedding, and you can call the simple RNN as well, right? Because we want to build the model for the simple RNN, right? Okay, now we have call everything. Let's just call one more thing that is called sequential model that we want. So you have to call the from TensorFlow dot Keras dot preprocessing, and let's just call the sequence one, right? Okay, perfect. Let's just call this one. Now I think we have imported everything. Let's just finally call the data set. So from TensorFlow, let's just call this one preprocessing label encoder. Label encoder is not required. So from TensorFlow, see, that is the reason we are living in an era where we can simply write the code and it can be like particularly performed by the model itself, right? If I just simply call my data set now, it will understand, okay, we are working in this data set, right? So from TensorFlow dot Keras, from TensorFlow dot Keras dot datasets, okay, and let me call the IMDb dataset. Okay, yes, this is the dataset that we want. Okay, now let me just simply write the done. Now because we have called this IMDb, now it will understand, okay, we are building a project for this IMDb one, right? Now if I just write any of the code, it will try to give the suggestion for the load the dataset. Let's just try to load the data set. Okay, what exactly data set that we want? We know that now we have to work on like the feature part as well. Okay, so let's just call the 1,000 feature or like 100,000 feature. We can call, okay, just only give me the data set for the given set of features, right? So let's just write this as a max features. I'll just write this as a max features, FEATURES. Max features is equals to 10,000. You can write 10,000 like this. This is like going to be my vocabulary size. The previous, we have that vocabulary size of the 40 now. So we are just calling the vocabulary size of 10,000 features, right? So let's just call my model. And how to call my model? I'll just simply hit this IMDb. Inside this, I'll get my method, which is called load data. And I'll just simply give the number of words that we want. And we know that the number of word is like the maximum features. Okay. When I run this now class, this will give me the xtrain, xtest, ytrain, and ytest data set directly. Okay. So what to do? You can just simply write this one. Okay. Xtrain, let's just write is equals to here, then so that it can give some hint. Xtrain, comma, ytrain. Not getting the hint, no issue. Then you have to give xtest, comma, ytest. Let's just run this, right? So we got this data, we have downloaded this data. Class, I hope everyone is getting not enough values to unpack. What is the issue, right? Let me just check this one. I think we have used xtrain. Expected 2 got 4. What is the issue? Expected 2 got 4. Xtrain, ytrain, xtest, and ytest. And the number of words that we are looking for is like the maximum features, xtrain, ytrain, xtest, and ytest. Okay, let's just do this in this way, and this is like my one, and let's just consider this for the 2 1. Okay, so that it will just try to pass out the data set. Just one go. Okay, yes, that was the main issue, right? Okay, see, whenever it asking for like unpacking issue, so you can just simply unpack this data using the brackets as well, right? So now let's just quickly check the xtrain dot shape, comma, xtest dot shape. Okay, this is the data set that we have. Extend both 25,000 and 25,000 data set right now. Okay, now let's just try to check the simple review of what exactly the review kind of we have, right? So let's just call this data set xtrain, and let's just call the 0 1. Okay. Oh, what is the issue? Why we are getting the data directly in like a numerical format? Because it has already used this technique, the embedding technique, or like the vocabulary index technique. We have to reiterate the each values, and then we can simply check. Okay. So xtrain 0 is like this numerical value. Let's just go to this one, check with the ytrain value. What exactly the ytrain value is? Ytrain we will get the 0 and 1. 0 and 1s are like the positive review or like the negative review candidate, right? So let's just try to call one review for my model, right? What exactly my model is, and that is called particularly the sampling of my model, right? So you can just simply call this one xtrain. Go to this xtrain 0 and let's just call this as a sample review, review, and again copy this one, just paste it here, and this is like my sample label. Whatever the output that we are getting, it should be based on y train 0. Okay, now we want to print the value directly, not in a form of numerical one, but in a form of words, or like a complete sentence or like a meaningful way. Okay, so let's just map each index. These are my index, whatever the values that we are getting. Let's map each index to original words, then we'll understand. Okay, for that you have to use the IMDb concept itself. Let's just call the word index the way we have the vocabulary index. So just go to this IMDb, and inside this you will get this method which is called the get word index, right? If you just run this, you have downloaded this get word index. Now you have to use the reverse key iteration, and that is called the dict comprehension. So you can just simply call for key comma value in whatever the word index dot items we have. This word index is like it's in a form of dictionary. So we are just calling this key and value, and we are just changing the value to key. Why we are changing this for value to key? So that if we just pass a value, na, it should return me the key instead of the value itself, right? And let's just say this as a reserved, not reserved, it's like the reverse word index. Okay, this is like my reverse word index, and let's just call this one reverse word index. This is the use of a comprehension, and you can just check at this index we have this one, which is the fairy word, right? Now I want to call my word, right? Whatever the extrain data set that we have. So how to call this one? You can use the string method that is called the join approach. With the help of that join, you can particularly call your model, right? So how to call this one? Let's just scroll this one. We'll get like a very huge amount of data set we have. Okay, so let's just call this as a decoded decoded review is equals to, you will use this technique which is called the like string join approach. You will use the join method, and let me just show this right first, then you can understand. If I just simply want to join my this word, the first word is hello, second one is world, okay, and third one is I, fourth one is love, and fifth one is Python. So it will just try and join all my data set, right? And the final will become hello world, I love Python. So instead of this list, what I want to pass my data set, and just look at this. I'm directly getting the hint, right? So I'll use this one reverse word index, and based on that, I'll just run a for loop over my sample review, and I'll just use the get method. Get method is like my index method, whatever the method that we'll get. If I'll not get any sort of word, that I'll simply replace with this question mark, right? Whatever the I value that we will get, the starting value is like more than 3. So we are just subtracting the value of I to -3, right? And let's just simply pass this inside a decoded review, decoded, decoded. Okay. And if you just run this, then you can simply check, okay, so the sample review, REVIEW, the sample review was something this, but if I want to get the decoded review, so instead of this, you can just simply print your decoded review, print decoded, decoded review, right? And this is the answer candidate that you are getting, right? Where's the decoded review, right? Perfect. So this film was just a brilliant casting location scenario. Question mark 1. This 22. 16 will be represented as a was. 43 was just. 530 was brilliant. 973 is the casting. 1622 is my location. And that is the main reason we are particularly printing like this. I hope everyone is getting my point. Guys, is there any doubt or any sort of issue? Just let me know, candidate. Class, any confusion? In the same, like with the help of this, we can simply convert our data from the numerical to textual one, because we want to simply understand what exactly these reviews are. Okay, so if you want to print that review so that we can completely save, so you can just pass this without print method, right? A print function, so you can get this. Now let's just try to understand this data set. Okay, if I just simply pick my x string, okay, so inside this x string, let's just call the shape of this. Okay, the spelling, the attribute of shape is, I think, incorrect. So let's just correct this one. So we are getting, okay, we are not getting the shape. So let's just go to this. I'll just simply check np dot array, and I'll just simply call the shape. Okay, now the data set we have is like 280. Okay, the problem with that now, let's just simply call any random array, right? Now just look at this. The data set that we are getting is like 888. Let's just call any sort of any index. We are getting 221. Let's just call 129 index. We are getting 30C. That is the problem. We cannot particularly give a data with different dimensions. So we have to keep that data in a set of same dimension. And how to do this? Let me just show this. If I have a word, I love Python, and the second one is like, I love Java also. The third is like, I don't know what to do with PHP. Okay. So class, in this, you can just say, okay, you have three different set of words. The length is 3, the exchange shape is 3, exchange shape is like 4, and exchange shape is a 1, 2, KN, KNOW, and the length is like 1, 2, 3, 4, 5, 6, 7, 8. So this becomes a problem for your model. So what you will do, you will just use a padding technique, and that is called padding technique. The way we have used in the like kind of image like was the CNN problem. Na? So we have to use the padding sequence technique. Okay. SEQUENC. And what is that padding sequence technique? So it will just give two types of padding. The first one is called pre-padding and second one is called the post-padding. Now, this will convert the maximum value of my data set. Okay. And this will just try to give the pre-padding is like this, 4, 5, and then it will give the index value of this one. Let's just say the I index value is 12 and love is 23 and Python is 34. Perfect. Now you will do the same with this one. Okay. Now in this we have 4 index. So let's just do the pre-padding. So this will give I 23 and Java is like 45 and something is like 56. Okay. Now let's just do with the I don't know as well. Okay. So now you will get the same as 12 and something like 9, 8, 7. Just do any random stuff so that you can just simply understand the 8 values, right? So 4, 5, 6, 7, and 8. So this is called my padding technique. Now you can just check the shape will become something like, if I just simply comment out this one. So the values will be like both of 8 shape, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. This technique is called pre-technique, pre-padding sequence, because we are applying extra zeros at just pre. And there is another technique that you can use post. Post is like you have to apply the zeros at the last, right, to make the data shape at the same level. So how to do this? So you have to call this one. We have, I think we have already imported this one, right? So let's just call this one. Maximum length of padding that we want. See, if you just simply pick the maximum length of training, right? Let's just, you have to run the for loop over or extrain, then you have to find the maximum length. So it's over to you. You can just simply decide your maximum length. So let's just write the maximum length is like this. And now we will apply the padding technique for my extrain. So what I'll do, I'll just call my sequence. I have already called this one sequence. And inside this, we have this pad sequence. And what I want to pad sequence my extrain data set. Okay. And whatever the maximum length, you can just simply give your max length is equals to maximum length. Perfect. And you have to do this for the X test part as well. Let's just copy this one. And do this for the X test as well. Sequence.pad, and instead of X train, we have to pass the X test. And now just run this one. It will take some time, and you can just simply go and check the xtrain.shape. And now just simply call any of the data set. Xtrain, call any of the data set or dot shape. You'll get the same value 5. Okay, you can just change any value. You will get the same value. I hope everyone is getting my point, candidate. Okay, so let's just keep this for today. And we will just completely build the model for like tomorrow class, and then we can simply deploy the model. I hope everyone is getting my point, guys. Is that clear? Okay. So because within 1 minute, we cannot create a model, right? So let's just keep this for today. And we have particularly used this technique. And let me just share this report with you so that you, if you want to do practice, you can do this, right? And then let's just connect tomorrow for the final class. And if you want any sort of questions or any sort of queries, then you can let me know. We have like multiple things in this particularly AI era to understand and learn multiple things, right? So let me just share this with one, and so that you can practice, right? So this is for the today candidate. Wish you all the best. Taruna, any doubts, Spurti? Or shall we close this one? I think it's good to go, right? Okay, so tomorrow will be the final, I think, from my side. So let's just connect tomorrow, the same timing. Okay, Taruna. Very good, right? Okay. Bye-bye. Wish you all the best.